Hello class, myself Supriya Gadke. Today I am discuss the new topic, that is complex integration and conformal mapping. So first I am discuss the Cauchy theorem. If f of z is analytic on and within a closed curve C, then integration over C f of z dz is 0. Again I repeat, if f of z is analytic on and within a closed curve C, if any function, that is f of z, is analytic everywhere on that given closed curve, then integration around that closed curve is 0. Only important part is f of z is analytic everywhere in that closed curve, then integration is 0. When C is closed curve, integration over C f of z dz is denoted by integration, this symbol, over C f of z dz is called contour integral. This integral is called as contour integral. So next corollary is, using Cauchy's integral theorem, we shall prove that integration z1 to z2 f of z dz is independent of the path joining the point z1 and z2 if f of z is analytic function. If the function is analytic, that is not depend on path. Next corollary is, if f of z is analytic in a region R between two simple closed contours C and C1, then contour integral f of z dz over C is equal to contour integral on C1 f of z dz. These two integrals are same. Here this is the C path and this is the C1 path. If f of z is analytic in that region R between two simple closed curves, these two curves are closed, then contours C and C1 closed contours. So integration f of z dz over C is equal to integration f of z dz over C1. So now our next important formula is Cauchy's integral formula. That formula is, if f of z is analytic on and within closed contour C, and if A is any point within C, then f of A is equal to 1 upon 2 pi I integration over C f of z upon z minus a dz. This is the important formula. Again I repeat the concept. This is our closed contour C, and this f of z is analytic within this closed contour, and there is one point A. At that point z minus a is not defined. 1 upon z minus a is not defined for that a point. For that a point we have to write a function f of a, that is equal to 1 upon 2 pi I integration over C f of z upon z minus a dz. This is the Cauchy integral formula. Here f of z is analytic function and there is one point A such that 1 upon z minus a is not defined. Then we define new function, that is f of a, that is equal to 1 upon 2 pi I integration over C f of z upon z minus a dz. Corollaries of this Cauchy's integral formula are, f of a is equal to 1 upon 2 pi I integration over C f of z upon z minus a dz. If that a, that is singular point, that a appears one time, then we directly use this formula. If that a appears twice, that is z minus a square, then our formula becomes f dash of a is equal to 1 upon 2 pi I integration over C f of z upon z minus a square dz. If that a appears thrice, then our formula is f double dash of a is equal to 2 factorial upon 2 pi I integration over C, f of z upon z minus a cube. if that A appears 4 times, then f triple dash of A is equal to 3 factorial upon 2 pi I integration over C f of z upon z minus a raised to 4. In general, we write if that A appears n plus 1 times, then fn of A, that is nth derivative of f at point A, is equal to n factorial upon 2 pi I integration over C f of z upon z minus a raised to n plus 1. Now, by using these properties, we have to solve some problems. Evaluate integration over C sin 2z upon z plus pi by 3 raised to 4 dz, where closed contour C is equal to mod z equal to 2. So mod z equal to 2 is the circle with center origin, that is 0, with radius 2. Here is 1, here is 2. So our z plus pi by 3, we can write this z minus pi by 3. So our point A is minus pi by 3. Minus pi by 3 lies within this circle. So here our f of z is sin 2z. Sin 2z is analytic within z, within C, that is our C, and z is equal to minus pi by 3 is also within C, and that point minus pi by 3, z 1 upon z minus pi by 3 is not valid. So we used Cauchy integral formula's corollary. That corollary says fn of A is equal to n factorial upon 2 pi I integration over C f of z upon z minus a raised to n plus 1 dz. So we have to calculate contour integral over C sin 2z upon z plus pi by 3 raised to 4 dz. Here our A is minus pi by 3 and n is 3. Here n plus 1, so 4, that is 3 plus 1, so n is 3. F of z is sin 2z. Here sin 2z is always analytic everywhere. So f triple dash of A is equal to 3 factorial upon 2 pi I integration over C sin 2z upon z minus pi by 3 raised to 4 dz. Here we put the value of n is equal to 3 and A equal to minus pi by 3 here. So put the values here. F triple dash of A into 2 pi I. Take this value here. So this one 2 pi I is here in division. So here is in multiplication. F triple dash of A into 2 pi I. This term goes to division. So 3 factorial is equal to integration over C sin 2z upon z plus pi by 3 raised to 4 dz. As f of z is equal to sin 2z, f dash z is 2 cos 2z, f double dash z is minus 4 sin 2z, f triple dash z is equal to minus 8 cos 2z. So we have to find f triple dash of z at point A. Our A is minus pi by 3. So f triple dash at minus pi by 3 is equal to minus 8 times cos minus 2 pi by 3. But cos minus theta is cos theta. So minus 8 cos 2 pi by 3. But 2 pi by 3 we can write as pi minus pi by 3. But we have the value cos pi minus theta is minus cos theta. So that value is minus cos pi by 3. That minus and here minus become plus, that is equal to 8 cos pi by 3, that is equal to 8 into cos pi by 3 is 1 half, so 8 into 1 half, that is equal to 4. So integral contour over C sin 2z upon z plus pi by 3 raised to 4 dz is equal to f triple dash at minus pi by 3 into 2 pi I into 6 upon 6 is equal to 4 into, that is 4 into 2 pi I as it is upon 6, that is equal to 4 pi I upon 3. That is the final answer, 4 pi I upon 3. Thank you for watching this video.